Teacher Jerry here. Welcome back to the second part of the redox. In this, we are focusing on oxidation state. So we got to be very clear. Oxidation state, or sometimes people call it oxidation number, is not really equal to charge. Okay, by right, only ionic compound have charge because they transfer loose gain electrons, but covalent don't have. Covalent share electrons, but covalent will have oxidation state. So oxidation state is a concept that assume all the covalent will behave like ionic. So covalent is non-metal, non-metal. So that's why the challenging part or the tricky part is when we approach non-metals. So if you look at a fixed oxidation state, okay, these are the more fixed oxidation states. Group 1, Group 2, Group 13, they are metals, so they have no issue. They follow exactly the charge. Right? But take note the difference. Normally charge will put 1 plus, 2 plus, 3 plus. That's why whether we put the sign first or the number first is important because it's to differentiate between are we looking at oxidation state or are we looking at charge. Now, when you go non-metal, it's less fixed. Okay, group 17. So we need to be aware is that not every time group 17 will be minus 1. It's minus 1 most of the time. All right, oxygen and hydrogen is more or less fixed. We also define redox based on oxygen, hydrogen. But even that, in certain scenario, they do still change. For example, in hydrogen peroxide, H2O2, the oxygen here will be minus 1. Right? When hydrogen partner with a metal, for example, sodium hydride, then it will be minus 1 instead of plus 1. Because this add up will give you 0. Okay, metal has to be positive. All right, so do take note. We say oxygen is minus 2. We never say group 16. Unlike charge. No, charge will say that group 16 is minus 2. All right. Okay, so how do we do that? So why hydrogen peroxide is special because you realize that hydrogen peroxide can act as both an oxidizing and a reducing agent. Mainly, we need to learn how to calculate oxidation state. So how do we calculate oxidation state? We need to focus on the fixed oxidation states. All right. So technically, when we look at let's say all these like okay, these elements, so you can see all the element means only one of them will be 0. Okay, so no need to calculate. We don't care how many here, as long it can be S8, it can be Cl2. They're all element. There's only one element inside. All right. So when we look at CO, for example, we will focus on the one that is fixed. There's oxygen, so it's minus 2. So carbon, we don't know. It can be X or whatever letter you want to represent. It can be Y, it can be Z. Okay, this if no charge here, add up must give you 0. That's why the oxidation of carbon here will be a plus 2. If you got CO2, then the carbon here will be plus 4. All right, that's how we calculate. If you got CO3 2 minus, then they must add up to give you minus 2. So it's plus 4. All right, so you can see here, I just show you example. Okay, when you got Cl minus, take note. If you got Cl minus, it's not element. Element don't have charge. So if just Cl minus, it will just follow. Okay, minus 1. All right. So there is one here, NaClO, where the chlorine, even though it's group 17, is not minus 1. Because between all these elements, these two are more fixed. Plus 1, minus 2. No charge means must give you 0. So the Cl here is your plus 1. Right? So that's why we need to calculate. We cannot just assume. Okay? And more important thing, what happened if let's say I got two unknown, like for example, Cu SO4. Right? We got copper, sulfur that is unknown, that's not fixed. So we do is we split. We know that this SO4 2 minus, and then this is your Cu2 plus. Then we calculate them separately. Cu2 plus means your plus 2. This SO4, you can calculate as how we do here. Right? We concentrate oxygen is minus 2 times 4. Then sulfur will be X. Add up must give you minus 2 because SO4 2 minus. When you split them out, it's SO4 2 minus already. It's not just 0. Then we just calculate. Okay, plus 6. So how do we do that in the questions? Okay, how do we here is how we do it, all right? And take note, if we have two here, when we talk about oxidation state of copper, we are talking about one copper, not two, not three. It's always one element. That's something that we have to be careful of. Okay? How we calculate. So how we do a redox question, a typical redox question is either ask us which is what is oxidized, what is reduced, or what is the oxidizing agent, what is the reducing agent, and ask us to explain. All right? You can ask us to explain in terms of oxidation state, in terms of gain loss, oxygen, hydrogen, or even electrons. If the question never says so, then whichever you want to use is fine. So by default, I train students or we should practice oxidation state. because now it takes a bit of time to calculate. But once you get used to it, it's a skill, you practice it, it will become easier and you take shorter time to it. All right, and oxidation state applies for all kinds of equation, whether they involve oxygen, hydrogen or not. So we look at typical equation Fe, so element 0, we calculate first. Then this chlorine is 17, so minus 1 times 2. All right, then copper must be plus 2. All right, then similarly, between iron and chlorine, chlorine is more fixed because iron is transition metal, right? It don't really belong to any group. So then chlorine minus 1 times 2, then Fe will be plus 2. Right, then copper element 0. So we then, after we calculate, then we compare. Iron before reaction is 0, after reaction is plus 2. Okay, so we call this increase in oxidation state. That's why it's oxidized. All right, so we say it's oxidized, you see. Then we say oxidation iron increase from 0 to plus 2. Right, we can also talk about electrons, you can see. Because why it becomes 0 to plus 2, there's an increase because you lose electrons. If you look back at your shoe, all right, indeed, increase in oxidation states means you lose electrons, right? Become more positive, right? So if the question asks in terms of gain lost electrons, then we will explain in terms of electrons. If not, you want to put in oxidation state also can. You want to put in electrons also can, right? So if Fe is oxidized, so then let's look at Cu. See, it's plus 2 to 0. So there's a decrease in the oxidation state. So it's reduced. You see, so see when you say the substance, we say the whole thing. We don't just say Cu unless the question say which element is reduced, then we put copper. If not, we have put CuCl2 or we put a Cu2 plus, or we say copper in CuCl2. Right? So you realize it's always one of the reactants. Okay, if you put Cu, then it's like the product. The product don't go through reaction, it's the reactants that go through reaction. Right? Similarly, okay, so when we explain, we pinpoint what is the element that changed. So plus 2 to 0 in copper, or you can say gain 2 electrons because there's a decrease in oxidation states. We mentioned it now, oxidized, when you're oxidized, means you are a reducing age, you are reducing agent. So you see, okay, so the reason to explain reducing agent, oxidizing agent, there can be two ways. You can either say that it is reduced. Or you can either share that it reduces who it reduces. In this case, it reduces copper to chloride, or you can explain that itself is oxidized. There are two possible ways. Okay, and similarly, likewise, you can see that reduce means it's an oxidizing agent. Right? Or if the question asks if this is a redox reaction, then we have to mention both oxidize and reduce. Then together it's called redox. So it takes a bit of practice to get used to it. It look a bit more challenging, but actually the questions asked is very fixed. You just have to get used to calculating oxidation state and learning how to compare. And when you write the explanation, you can just take note that actually it will be the same old phrasing. All right. So have fun trying. I'll catch you in the next chapter, and that's all for redox.